In this video we're going to go over some of the basic trig functions and their values in the first quadrant at the sort of standard reference angles. And at some point you just need to kind of know these or know how to get them on your scientific calculator if you're allowed. There are some neat little tricks as to how to fill this table in, sort of quick memory tricks that make it easier to do, but I just want to spend at least a little bit of time looking at the unit circle and exactly where all these things come from. Now for degrees, I think we're used to thinking about this as 0 degrees, this is 180 degrees as you go around, and then if you keep going around, we know that it takes 360 degrees to do a full revolution around a circle. But in calculus and in Precalc, we generally don't deal with degrees, we deal with radians. So we have to think about what it takes to go around a circle. We know that it's 0 radians at the beginning, and if you remember from basic geometry, the circumference around the unit circle is 2 pi. Okay, so it takes 2 pi radians to go all the way around. Now if it takes 2 pi to go all the way around, it should only take pi to go half of the way around, and it should take, then cut that in half to get pi over 2. And then the bottom over here, right, you're 3/4 of the way around, 3/4 of 2 pi, or an extra pi over 2, right? You're basically 1.5 pi or 3/2 pi. Okay? And at some point, you want to be able to kind of get some quick reference points on this unit circle. Splitting the first quadrant in half gives you pi over 4, that's half a pi over 2. And then, the other two that sometimes people get mixed up are the pi over 6 and pi over 3 angles. Right? Well, dividing pi by 6 is going to be a smaller value than dividing pi by 3, so this must be the smaller angle, pi over 6, and this is the larger one, pi over 3. Okay. Now, at some point, if it's easier for you to always think of them as 30, 45, 60 degrees, and then convert, you could do that. It's an extra step. I think if you can learn to think in radians, things get a lot easier, right? And then, you going back to your basic right triangle trig, we know that the radius for all of these is 1, right? And you can kind of figure out using the 30, 60, 90 triangle or the 45-degree triangle what these values are, okay? So at some point you've got to get comfortable doing this without bringing a sheet in. I know in Precalc some people sort of have the unit circle in front of them and they're allowed to bring it in. At some point you want to get comfortable with it. So one of the things that people can usually remember is that the sine of pi over 4, right, that's the halfway through, it's root of 2 over 2, and the cosine is the same. Okay. Now if we go back to the unit circle and we think about 0 degrees, right, the sine is always the y coordinate and the cosine is always the x coordinate on the unit circle, right? And the x coordinate starts over here at 1, right, and makes itself its way all the way up to 0, right? And the y coordinate starts at 0 and makes its way all the way up to 1. Okay? So the sine is 0, the y coordinate at 0 is 0, the x coordinate at 0 radians is 1. We have the flip side over here, right? And one of the neat little tricks, especially if you can remember what the other two values are, a half and square root of 3 over 2, and again, I don't want to spend a whole bunch of time reestablishing those values. You have to know something at some point. Basically, this one counts up, and this one counts down. So what do I mean by counting up and counting down? Well, think of this as the square root of 0 over 2, the square root of 1 over 2, the square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. Right? If you simplify, the square root of 0 over 2 just becomes 0. The square root of 1 is 1, that becomes a half. Square root of 2 over 2 doesn't simplify, the square root of 3 over 2 doesn't simplify, square root of 4 is 2, 2 over 2 is 1. So one way to sort of generate this column is to put the denominator over 2, square root of 0, square root of 1, square root of 2, square root of 3, square root of 4, and simplify. Okay? And then, whatever you did for the sine values, you're just going to reverse for the cosines. Okay? And then the tangent, right, is really the sine over the cosine. So 0 over 1 is 0. Now when you do a half over square root of 3/2, right, the 2's are going to divide out, or you can do the reciprocal. You're going to get 1 over the root of 3, right, which we rationalize the denominator to be square root of 3 over 3. Okay. For pi over 4, the sine and the cosine are the same, so when you divide them, you get 1. For this one, you're going to have the square root of 3 over 1, right, which is square root of 3. And then this one is undefined. And, tangent is undefined at any odd multiple of pi over 2. It does have a domain restriction because it's sine over cosine. Anytime the denominator cosine becomes 0, then the entire value becomes undefined, right? The ratio becomes undefined. So at some point you have to kind of know these, and like with most things, when you're trying to recall all the stuff you've learned in previous semesters, you don't have to know it right away, but it's nice to have some sort of tools you can use. And if you can, remember these two but get them mixed up, you could always figure that out. The smaller one, right, a half is smaller than the square root of 3 over 2, and since the sign on the unit circle, right, the y-coordinate here is going to be less than the y-coordinate here. So you have to choose between a half and the square root of 3 over 2. It's pretty easy to see which one would be which. So at some point, the idea is to get used to doing this and knowing these values so that when you get to questions over here on the right, the same angle sort of projected into other quadrants, you know what to do. So when you get to something like the sine of 7 pi over 6, the first thing to recognize is that you're looking at pi over 6 as a reference angle. Right? It's some multiple of pi over 6. Now, how many pi over 6's is it? Well, it's 7 of them. Okay? And if you draw your unit circle, right, and you're thinking about pi over 6's, this is 0, this is pi, right? But in terms of pi over 6's, it's really 6 pi over 6. Right? And if you can get used to counting in these fraction terms, it's a lot easier to kind of move around rather than trying to memorize and do a lot of extra arithmetic. Right? So 6 over 6 pi is really just pi. And what that shows you is that 7 pi over 6 is right down here. Right? Just one more pi over 6 from 6 pi over 6 gives you 7 pi over 6. So you've got, your pi over 6 down here. This is 7 pi over 6 all the way around here. Right? I'll just label it so it's there, 7 pi over 6. And then you want the sign, you want the y-coordinate. Well, once you recognized that 7 pi over 6 was going to come from pi over 6, we knew it was going to be a half. We just didn't know if it was positive or negative. And since we're talking about a y-coordinate, anytime you dip below the y-axis, the x-axis, right? Anytime you dip below the x-axis, your y-coordinates are negative. So this is negative a half. There's also a neat little memorization technique. All students take calculus. I've heard all students take cookies. The letter here represents which of the trig functions, the three basic ones, are positive. So in the first quadrant, they're all positive. In the second quadrant, only the sine is positive. In the third quadrant, only the tangent is positive. And in the fourth quadrant, only the cosine is positive. So, whether you want to think about it in terms of x and y, plus or minus, that's really up to you. Whatever works, right? That's the real goal. The techniques and tricks and shortcuts only help if they work. So whatever it takes for you, you're going to have to spend some time figuring out. Okay. For this cosine of 2 pi over 3, again, you're talking about a pi over 3 reference angle, so we're going to be looking over here. And since we're talking about cosine, we know the answer is going to be either plus a half or minus a half, right? It just depends on where you end up. Right? So where does 2 pi over 3 fall on our unit circle? Well, again, let's give it some reference. This is 3 pi over 3. Right? So 2 pi over 3 is going to be 2/3 of the way there. This will be 2 pi over 3. Now, since you're in the second quadrant, you're in the negative x zone, right? Anytime you move across the y-axis to the left of the y-axis, you're negative. So this would also be negative a half. Okay? Now, this last one, 13 pi over 4, right now you're in the pi over 4 row, and whether it's sine or cosine, it's going to be square root of 2 over 2. In this case, it's tangent. So we know it's a 1, and again, what kind of 1 are we talking about? Positive 1, negative 1, right? What do we need to do? So I'm just going to clear a little space here, and we're going to come up with counting by pi over 4s, right? So I know this is 4 pi over 4. I know this will be 8 pi over 4. Right? 2 pi. This will then become 12 pi over 4, which again, puts 13 pi over 4 right down here in the third quadrant. Right? So I go 4, 8, 12, 13, right? It's going to put me in the third quadrant. And in the third quadrant, my tangent is positive, so this will be positive 1. Now, you certainly don't have to put the plus. We assume 1 is positive 1, but I'm just putting it there to sort of indicate that we thought about it. Okay? So, whatever it takes for you to kind of get these values back and make them comfortable, throughout calculus, you'll be having to compute some basic trig functions and values in different quadrants, right? So again, sine of 5 pi over 4, I'm going to do the same way. Right? I know this is 4 pi over 4. 5 pi over 4 puts me right here. Right? This is 5 pi over 4. The sine, I know it's square root of 2 over 2. And because I'm in the third quadrant, my y-coordinate is negative. Right? That's going to be negative square root of 2 over 2. Now, this last problem over here that we're going to work out in this video, there's this negative 1 exponent for tangent. And it kind of looks like a negative exponent, which would be 1 over. But in function representation, that negative 1 exponent really is inverse function. Now, a lot of calculus textbooks use arctan as an inverse function, meaning the angle whose tangent is such and such. And that way, that negative 1 doesn't get confused as an exponent. So you might find it easier, and maybe the notation you're going to be using this semester would be the arctangent of square root of 3. Now what they're really asking you is the tangent of what angle is going to give you square root of 3. Okay? Now you can go back to that table, right? And if you have it, or you want to generate it so it's there for you to look at, that's great. Otherwise, you could think about the sine of theta over the cosine of theta being the square root of 3, and think about that as over 1, and then just add a half and a half, right? Because that's where we know that the reason we got that square root of 3 was the denominators sort of took care of each other when we simplified. So what sine is going to give you 3 halves, and what cosine is going to give you 1 half? Well, that's pi over 3. Okay, so we could fill in pi over 3. The answer here is pi over 3. Okay. So you're going to, not spend a lot of time explaining this over the course of the semester. You're going to be expected to kind of know this. And, this is just one of the ways you can start to think about figuring out trig values in different quadrants, figuring out inverse trig values, and so on. So, as always, you got to practice a little bit, but hopefully it'll get easier. And maybe if you can think about moving around in fraction terms based on your reference angle, that'll make it easier to find where you end up.